Child, you may have experimented with this technique in the past, using your magnifying glass to create power, and you were probably using that power to kill small insects, which is not something I condone, but there you have it. Sunlight carries a lot of energy. If you concentrate it into one place, you can do a lot of work. And I'd prefer if we would be using that work to push electrons into your house so that you can watch me on your computer screen, not to use it to vaporize small animals. Lenses like this are far too expensive to use in solar power plants, so instead we use mirrors. These are called concentrated solar power plants, and in general, what's done is you use the mirrors to focus light on a single point, and there's two real ways that it's done. One, you build a giant tower, and then you fill a field with mirrors, and you make sure that the mirrors are always focusing the sun on the top of that tower. Now, as you might expect, building a giant tower that can handle being heated to some ridiculous heat kind of expensive, but it is cheaper than pure photovoltaics. The other way that concentrated solar power works is they'll build giant mirrored troughs, like parabolic sort of half cylinders, and in the middle of those they'll put a pipe. So by the time the oil is finished traveling through this parabolic trough, it is so hot that as soon as it enters a vat of water, the water immediately vaporizes. And that's generally how power plants work. You vaporize water, and the vapor takes up much more space than the liquid. And so there's a tremendous amount of pressure, and they use that pressure to drive a turbine, which creates electricity. But even with all that fancy engineering, concentrated solar power plants still, in the best of circumstances, only produce power at about 11 cents per kilowatt hour, which is about twice as much as a natural gas power plant. But wait a minute, now we've got two solar solutions. One, photovoltaics, where the capture of the energy is the most expensive part. And two, concentrated solar power, where the conversion of the energy into electricity is the expensive part. What if we could have both of these technologies and have the best of both worlds? Well, it turns out that we can, and it may just be the one solution that allows solar power to become cost-effective in our energy market. By using really sophisticated photovoltaic cells that can take in far more power than the one in your calculator, engineers and scientists are using mirrors to concentrate light on very small photovoltaic cells. The mirrors, which are actually capturing the light, are 10 times bigger than the solar panel, and thus the solar panel is taking in 10 times more sunlight and producing 10 times more energy, but the solar panel itself, the expensive part, stays the same size. Using this technique, which we call concentrated photovoltaics, we get the most cost-effective form of solar power that we currently have on the market today. They call it CPV for concentrated photovoltaics, and there are several gigawatts of it getting ready to go online in the next 10 years or so. It's important to note, a gigawatt is a lot of electricity. That's about as much as produced by the largest nuclear power plants in America. Going back to the space station for a moment, mostly just because I want to show more of the awesome graphics of the space station. As I said before, it doesn't matter how expensive the solar panels on the space station are, because there's no other way to get power up there. And when I said that those solar panels produce about 120 kilowatts of electricity, I was kind of lying to you. About half the time the panels on the space station are producing 0 watts of power, and that's because it's in the shadow of the Earth. And here on Earth, when we're standing here, we call that shadow nighttime. And it is the nemesis of solar power. And so, unfortunately, it would seem that solar power could never satisfy 100% of our energy needs. We'll always need something else, whether it's coal or nuclear or natural gas, to keep the lights on at night. Unless, of course, we could find some way to store the power up during the day, and then let it all loose at night. Well, it turns out we kind of can't. We can pump it up hills and then during the night let the water fall down through turbines generating electricity, or we can pressurize giant closed caverns in the earth to thousands of psi during the day, let the air escape to generate electricity. We can heat salt until it melts and then use the molten salt to boil water at night, or we can use the solar power during the day to split water into hydrogen and oxygen, and then use the hydrogen in fuel cells to generate power at night. But unfortunately, solar power is obviously already really expensive, and each one of these solutions to store that power adds to the price. So while it's feasible and we have created the solutions, implementing them is just not in the near term. And in physics, we have a thing called the law of conservation of energy, which says that you can't get more out of the system than you put in. Well, in economics, there might as well be a law of conservation of dollars, which says that people aren't going to put more in than they have to in order to get a certain amount of work done. Why would I climb over a mountain if someone's already built a tunnel through it? I mean, aside from the obvious fact that that tunnel releases hundreds of megatons of carbon dioxide and other pollution into the atmosphere every single year. Meanwhile, the biggest power plants in America produce around 1,000 megawatts of electricity. If we had 116 billion of those, it would be just enough to match the amount of power that the sun shines down on our little planet every single day. I'm going to agree, solar power is awesome. I hope you learned something.
Started my Camry. Remembered the choices I made. And realized,
does anybody want to share any of the facts that they learned from the video?
All weather is created by the sun.
Good. Alright,
We are reliable on coal and oil.
yeah, that's true. It's those are two fossil foods we use like every single day. Anyone else? You?
The solar panels that you get are really expensive compared to, I can't remember the other ones, but they're like really expensive compared to the others.
Yeah, the solar panels are very expensive compared to other systems. Back here.
Solar panels are more efficient, huh?
Desert collects more energy in 6 hours than the world does in a year.
It's pretty crazy. Like,
Yes.
in one day, the sun is shining on Earth. If the whole Earth was a solar panel, in one day we would have enough power to like suffice our generation and like the next. I believe we'd have pretty much free power from the sun for years to come, just in one day of absorbing all the sun's rays. Anyone else have any facts?
Basically what a solar panel is a negative silicon and a positive silicon connected by a conductive wire at the sun.
I was just about to see you paying attention. Any other facts? Anybody else? Okay, yeah, Edmund Becquerel, he discovered the PV cell. Alright, does anybody else have any facts they want to share? Good. Alright, now I have a word search. It's just got words all about solar energy and alternative energy, so if you would take the time to complete that, it's not too difficult. It's pretty self-explanatory.
I finished one of these
Really?
Yeah.
That's impressive.
Can you put the camera on me?
I'll hold this one side.
Okay, Willie.
Follow me on Twitter.
No, might break it.
Right there.